kids, are you ready for class today?
I'm so pumped for knowledge. Did you know that the square root of pi is 1.77244553?
Chocolate pie.
You are all stupid. I am so cool. A.
Okay, kids, calm down. We're here to learn, remember?
But we already know this stuff. Did you know that at CERN they have a supercomputer that can run quantum sublay simulations on quantum entanglement of binary black holes?
Okay, today we're going to learn about atoms.
Who's Adam?
What are we gonna learn about first?
Well, let's start with the Democritus model.
Ooh, I know that. Democritus thought that all matter was made up of small pieces called atoms. These atoms were varying in shape and size, but were indestructible.
That's right, Reese. Democritus first made his model in ancient Greek times, and it persisted until 1808, when John Dalton proved that all atoms of the same element are the same.
So like atoms of earth and atoms of fire and atoms of water and stuff?
No, those aren't elements. Elements are stuff like hydrogen and iron and uranium.
You two calm down, or I'm going to give you both lunch detention. Alright, can I carry on now?
Yeah.
Yes?
Mm-hmm.
Yeah.
Yeah?
Mm-hmm.
Are you going to be fooling around again?
Yep.
No.
Okay, so the next person's model, Thomson's model, was pretty lame because he thought the world was made of plum pudding.
The world is obviously made of chocolate pie.
No, the world wasn't literally made of plum pudding or chocolate pie. Thomson just thought that the atoms were made of a mush and were malleable.
Thomson's model really didn't last that long, and after 11 years, Rutherford did his gold foil experiment, and he saw the light scattering. Came up with the billiard ball model, where light bounces off atoms like billiard balls.
Max, you better not say something dumb again.
What does dumb mean?
And this is why humanity is failing.
Next model, the Bohr model.
Ooh, I know, that has electrons.
Smart, Jonathan, and that is the most useful thing you have said this morning, and the only one, too. Bohr discovered the electron when researching metals, and made the idea that light was deflected by electrons rather than being deflected by the nucleus itself.
So the atoms of Bohr threw an electron at the light and hid it away?
Can we talk about Schrodinger's cat and quantum entanglement and virtual particles and stuff now?
Actually, that's part of the final atomic model and the one we use today. In 1926, Schrödinger utilized the Heisenberg uncertainty theory to develop a theory about the way electrons act. Heisenberg
said that it was impossible to know the exact details of some atomic particles, and Schrödinger followed up on that by saying the electrons were not in a definite orbit, but rather in a probability field. Electrons could be on one side of an atom, not exist briefly, or even be in two places at once.
Be smart, but you are not the teacher here. Remember to let me speak while I'm speaking. Alright?
Fine.
Okay. Although you are right. Basically, quantum theory makes no sense if you think about it too much. So it's just better to know that Schrödinger said that electrons absorbed light, got bumped up in energy, and then spat the light back out again and went back down in energy.
So light is coffee and chocolate pie, but for electrons?
Stop with the chocolate pie and study for once.
Well, I already have an A, so you two can go study or do your own thing or something.
Okay, well, we're out of time, so class dismissed.